In this video, we're going to graph exponential functions with an a value that both grow and decay over time. So before we start graphing exponential functions, let's review what an exponential function actually is. An exponential function is an equation written in the form y equals a times b to the power of x. So there are little additions we can add in there with additional transformations, but for right now we're going to stick with the basic y equals a times b to the power of x. Now some key details that tell you this is an exponential function really consist of the fact that the x is in the exponent. So when that independent variable is in your exponent, that makes this an exponential function. And all exponential functions are going to have the same general shape to them. So they're going to have this little swoosh shape that's either going to look like this or like this. And then they can reflect over that x-axis as well. But either they grow exponentially over time or they decay exponentially over time. Now, this graph here is called an exponential growth function. And you can tell it's a growth function by looking at the particular graph and noticing that as we read the graph from left to right, the graph begins to grow and go upwards very, 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 very quickly. Now, if we look at this other one, this is called an exponential decay function. And that, again, is because when we read the graph from left to right, this graph is going down and it's getting very, very close to this x-axis. Now, one key detail that we need to know about these exponential functions is that they have something called a horizontal asymptote, which is basically an imaginary line here, which in this case of both of these graphs, it's right here, so I'm going to make it dotted. They have an imaginary line here that they essentially can't cross. So our graphs get very, 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 very close, but do not cross this line. So these graphs have a horizontal asymptote. And in this case of these two graphs that we have here, our horizontal asymptote is on the line y is equal to 0. And we'll talk further about how to find horizontal asymptotes, but they're basically an imaginary line that our graph is incapable of crossing. It can only get really, really close to it. So we're going to dive in and practice graphing these exponential functions, and we're going to determine with each if we have growth or decay and look for some patterns that might help us determine if it's growth or decay just by looking at the equation. So let's begin by making a graph of an exponential function. So here we know that we have an exponential function because of this x value here up in the exponent. So we know it's going to have a swoosh type of graph. Now from here I'm going to make a table of values, and I'm just going to make that table of values from -2 to 2 just to see what happens. So I'm going to take my x values, substitute them into my function here in place of x, and I'm going to determine what my corresponding y values are for each x value. Now I'm going to have to use my knowledge of exponent properties to help me here in order to find an accurate answer. So if we start here with -2, we have y equals 2 times 4 to the power of -2. Now if we remember, we can make any exponent positive by flipping it into the denominator. So we have 2 over 4 squared, which is 2 over 16, which is 1/8. So when x is -2, y is 1/8. Then if I move on to the next one, y equals 2 times 4 to the power of -1. Well, I can flip that into the denominator to get 2 over 4 to the power of 1, which is 2 over 4, which is 1/2. Then I have 2 times 4 to the power of 0. Now, 4 to the power of 0, you might not know. If you plug that into your calculator, you're going to find that anything to the power of 0 is just 1. So this is 2 times 1, which is just 2. We got 4 to the first power, which is 2 times 4, which is 8. And then we have 4 to the second power, which is 2 times 16, which is 32. So here if we plot those points, we have x is -2, y is 1/8, so that's pretty low down there. X is -1, y is 1/2. X is 2, y is 0. And then it'll shoot through x is 1, y is 8. So it's going to go up that direction. And then remember it has that horizontal asymptote, or that line that it can't cross right here at 0. So that graph in blue is our function. Now I know because if I read the graph from left to right and it's shooting upwards, that this is an exponential growth function because it's growing over time. Now the way I can really tell that is by looking at this value right here. This 4, we're repeatedly multiplying by 4. That's what this is doing with an exponent. And so because we're repeatedly multiplying by 4, something that is larger than 1, our graph is going to grow very, very quickly. Now the last thing we need to find here is our domain and our range. When I look at my graph, I notice that it's going forever to the left and to the right. So that tells me that my domain is all real numbers. And then my range are all of the y values that are bigger than 0, but not touching 0 because I can't cross that line. So my range is y is greater than 0. There's no equal to under there because we're not crossing this line, but it's just y is greater than 0. So let's try a second example here. So we have our table of values. We're going to have x values -2 through 2. And we're going to substitute them in to find our corresponding y value. So we have y equals -2 times 2 to the power of -2. I want to move that into the denominator to make that exponent positive. So we have -2 over 2 to the power of 2, which is -2 over 4, which is a -1/2. We then have y equals -2 times 2 to the power of -1. So that's -2 over 2 to the power of 1, since we'll move that negative exponent into the denominator. So we have -2 over 2, which is -1. Y equals -2 times 2 to the 0th. Well, I remember anything to the power of 0 is just 1, so that's -2. Y equals -2 times 2 to the 1st, so that's -2 times 2, which is -4. And then y equals -2 times 2 squared, -2 times 4, which is -8. So then from here, we're going to graph these. So we have -2, -1/2, -1, -1, 0, -2, 1, -4, and 2, -8. Remember, we can't cross the x-axis, so it's just going to shoot up like that. Then from here, we need to find our domain and our range. Domain is going forever to the left and forever to the right, so we have all real numbers. Our range is below the x-axis, so we have y is less than 0 because it's all of the y values less than 0, but not quite crossing this horizontal asymptote here, so not quite hitting it. Then from here we look, and because 2, that multiplier number with the x as the exponent, is larger than 1, we have exponential growth. I know that it's shooting downward, but because it has a b value here, or a multiplier value with an exponent of x that is larger than 1, we have an exponential growth graph. And third and final example here. So let's make our table. We have -2, -1, 0, 1, and 2. So let's calculate our points here. So we have 4 times 1/2 to the power of -2. Well, that gets distributed to both, so we have 4 times 1 to the -2 over 2 to the -2. We'll flip those around so we get positive exponents. So we have 4 times 2 squared over 1 squared, which becomes, if I do 4 over 1 times 2 squared over 1 squared, becomes 4 over 1. So that is 16. Then if I move on to the next one, I have 4 times 1/2 to the power of -1. That becomes 4 times 1 to the negative 1 over 2 to the negative 1. We then can flip that fraction over, so we get 4 times 2 to the first over 1 to the first, which becomes 4 over 1 times 2 over 1, which becomes 8. Then have 4 times 1/2 to the power of 0. Well, anything to the power of 0 is just 1, so that's 4 times 1, which gives me 4. I then have 4 times 1/2 to the first power, so that's 4 times 1 to the first times 2 to the first. So here we have 4 over 1 times 1 over 2, which is 4 over 2, which is 2. And lastly, 4 times 1/2 to the power of 2, so it becomes 4 times 1 squared over 2 squared, which is 4 over 1 times 1 over 4, because 1 squared is 1, 2 squared is 4. So we get 4 over 4, which is 1. So if we graph this, 216 doesn't fit, but, negative 216 doesn't fit, but negative 1, 8 does fit, so we'll put that there. 0, 4, 1, 2, 2, 1. We can see it curving down here and getting very, very close to our x-axis. So there is our graph. Now we can see if we read this graph from left to right that it's going down over time and getting very, very close to that x-axis. We can also see here that our b value is a value that is less than 1. So if this value with the exponent of x is less than 1, something like 1/2, this is an exponential decay graph. Then from here, finding domain and range, we're going forever left and right, so our domain is all real numbers, and our range are all of the y values that are greater than 0 but not quite touching 0 because we have a horizontal asymptote here at the x-axis.